Hello everyone, this is Biplab Datta. Welcome to my YouTube channel. So today we'll discuss some problem, which is the first problem in the LeetCode problem set. This is labeled as easy. So let's go through the problem. Given an array of integers, nums, and integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, so there's a unique solution for each input, and you may not use the element twice. Okay, the same element twice to add up to the target, right? You can return the answer in any order. So basically, we want the indices of the two numbers. Okay, the two numbers which add up to target. Now, let's go to the examples. So we have a nums given, nums array 2, 7, 11, 15, and the target is 9. So if we let's not code it up, just let's see if we have to do it uh, numerically, manually, sorry, then what we have here. So if you just have a glance of the numbers, you can directly say which numbers will add up to the target. But since the computer we as human beings can see into like three dimensions, all right, so we don't have any problem in solving the problem like quickly. Okay, we can just see this thing. But for a computer which moves the pointer from one point to another like this, so we have we start with this one, then we let's say we took two, and then we keep changing and we iterate to the rest of the numbers. So this gives us 9. Then we take the other number. This gives us 13. And then we take the next number. This gives us 17. Okay, so we already have the number. This was a very straightforward example. We already have the solution. So the solution is basically this one. So this is the indices. The answer will be returned as 0 and 1. Okay, so since we have this is 0, this is 1, this is this is 2, this is 3, right? Right. So now we can keep on moving, like where if we take 7 and then add it to the next number, so this gives us 18. Then next 7, we have 15. Okay, this gives us 22. And similarly, we can go on with the rest of the numbers. Okay, so we already have the answer. We'll return this. So this is the answer. Now, this is what we have done is a brute force approach. Okay, we are having two variables. First loop is this, and then we have the second loop running from the rest of the for the rest of the array. Right. But we can improve on this. Now this is a very straightforward brute force approach. We can code it up, okay, quickly. So let's say we have for int I is equal to I less than nums length I plus plus. Then we have for int j is equal to I. It goes from I plus 1 to j less than nums length. Now this is j plus plus. And then we have, if we check nums I plus nums j is equal to target, okay, we return a new int array, which is the I comma j. So the order doesn't matter as the question says. So what we have here is now we have to return something here because Java doesn't allow you to, there has to be a return statement outside the loop. So this will be, let's say, if not found, let's return something which is -1 -1. Okay, so it's not required, but for this code to work, not have a compilation error, of a missing return statement, we can do this, right? So let's run this. Yeah, so this will be accepted. I've submitted a lot of times, and this is a very straightforward. So the time complexity of this is, since we have two loops running, one like, so we can directly, like, without calculation also we can say this, where n is the length of the number of elements in the array, and this is n square. If you want to explicitly calculate it, so what we can do is we can, let's say, if I equal to 0, so then j will go from 1 uh, to n minus 1, right? Now, so we have how many like iterations for I equal to 0? We'll have n. So there, no. This is n minus 1, and this is, uh, if we sum, so this is basically n minus 1, right? So we can write this is this is n minus 1. Now I equal to 1, so j will go from 2 to n minus 1 again, right? Now this will be n minus 1 minus, so this will reduce the number, right? So this will be minus, it will go for till minus 2, right? So you can, like, expand this. So this will be for I equal to n minus 1. J will be going from, like, it will just be n, and it will, the loop will not run. Okay. So basically this will amount to 0 iterations, right? So if you add them up, so n minus 1 plus n minus 2 plus so on up to, let's say, 1. So if we add them up, so we know how to add this is a number of terms, which is n minus 1 into the first term and the last, and the sum of the first and the last terms divided by 2. So this is basically, this is gives you n square minus n square minus n by 2. So we have 2 over here also by 2. So if you take the O of n, we go of n. So this will be basically n square, right? So we don't need to go into so much details. If you can just guess it by the number of loops you have. We have two loops with n, with n elements. So we can just take it from the, this is the leading term, right? N square. So this will be the, now for time space complexity, since we are not using any extra uh, data structure, so here it will be O of n. Okay, because the calculation takes O of n, this calculation, all right, and there is no other extra data structure other than the input. So input data structure is not considered in the space complexity part, and the output is also O of 1, right? All right. Now you can say there is that length is 2, but then again, it any constant O of any constant is basically O of 1, right? Provided the constant is a very small number. The constant is a constant; it doesn't matter, right? Sorry. Now this is done. Now we have to reduce the test space complexity, right? You can submit this. This will work. This might work. I don't, like, forgot. Now, how to reduce this thing? Now, if we are able to maintain some data structure where whatever we have seen earlier, the numbers which you have like, while parsing the array, we can store it. We can store it in there, so that at a later stage, whenever we require to look it up for some other number to pair it up as a sum to get the target, it will be easy for us to get the uh, uh, like, reduce the time complexity. Okay. Although we have a trade-off here that we have to use a data structure, so that will increase the space complexity. All right. So we know like, what is the data structure we need. That is the integer map. So let's, okay. So for int num in nums. Okay, we need the indices, so we cannot just iterate for all like that. So here we have if uh, map contains. Now this is the so let's create a temporary variable which has the so remainder you can say or something like that. So target minus nums. Uh, so so here the number is all positive number. Okay, 10 up to between 2 and 10 power 4. The length is 10, from 2 and to 10 power 4, and there is a negative number over here. So negative 10 to the power 10 minus 10 to the power 9 to plus 10 to the power 9. Now in this case, what we have here is we can just check if or we can directly check if target minus nums is present in the like in the this thing contains key. All right. So what we can do is we can return the answer as new int, uh, which is so we'll return the indices. So indices one is the current indices, which is I, or we can also do it like this. So let's get the first. So this is target minus nums from the map, and the other one is the current one. Okay, I, and if it's not present, so yeah, just put the uh, the nums. Okay, the current nums I. Basically, you have to get I here, the element, not the array, and put the index. Okay, now this is done. Or if it's not found there, so we can simply return minus one and minus one. Yeah, you can simply return an empty array also. Um, the problem doesn't mention anything. All right. So let's see, it should work. Oh, this should be missed in. Yeah, it should work now. Right. So let's submit this problem C, and yeah, so it works very fair. Like I've submitted many times, like for different languages. All right. Thank you for watching. Have a great day. Now, oh, okay, let me analyze the time complexity here. So here the time complexity is we are moving going over uh, the array only once. So that is the length. So if n is the length of the array, so what we have is O n. This is O of n, right? N is the number of elements in the array. And the space complexity, of course, we are using a map. So space complexity. Uh, so here we are storing. So in the worst case, what will happen is the element is at the first the pair which forms the target is one of the element is at the very starting of the array, at the zeroth index, and the other is at the end of the like other end of the array. So it needs to traverse the whole uh, this thing, the array, and the maximum size of the map which will be created is again n. So this is what we have. So you can see that we have to like there is always a trade-off between time complexity and space complexity. If you um, like we try to reduce the time complexity to from a quadratic to a linear. So we had to increase this space complexity over here. All right. So thank you for watching. Have a great day.